Here is the next example. In this example, he's asking us find ix value by using nodal analysis. So here basically here he's asking about nodal analysis, but we have to solve it by using super nodal analysis. Okay, why is that? We'll go through it in a minute. If he doesn't give you this v reference right there, then definitely we can solve it by using nodal analysis, because in that case we have a choice of choosing reference node at any point. So in the same video, next example, what I'm going to do, I'm going to solve the same example without having this ground, and we'll have a choice of choosing our own ground. Then it will be easier for us. But at this point, I'm going to solve this given example. Now, so step 1, choose all the nodes and label them, and choose one of them as reference. So in this case, he already gave us reference node, so we don't need to worry. So that's v1, v2, v3, and v4. Okay, our goal is, remember, finding ix. Now in the nodal analysis, our goal is shifted finding v2, because ix I can find by using v2 over 20. So now our goal is shifted to finding v2. Okay, now at v1, do we need to apply KCL? No, because as I mentioned, as long as you have a voltage source in between unknown node voltage and ground, so that unknown node voltage equal to the source value, source voltage. So here v1 equal to 20 volts. We don't need to apply KCL at v1. At v2, do we need to apply KCL? So what is our important first point? As long as there is a voltage source between v2 and reference node. Is this source is between v2 and reference? No, this is not between v2 and v reference. So for sure we have to apply KCL at v2. So now apply KCL at v2. Okay, apply KCL at v2. So here I'm going to choose every current is going out. So I'm going to choose this as I1, I2, I3, I4. Okay, so I1 plus I2 plus I3 plus I4 equal to 0. So now what is I1? I1 is nothing but V2 minus V1 over 10. What is I2? V2 minus 0 over 20. What is I3? I3 is nothing but negative 1. What is I4? So I4, most of the people are going to write this as V2 minus V3 over 40. This is wrong, because that 40 is the voltage. Okay, that's not a resistor. Okay, so you cannot write the voltage in the denominator. Basically voltage divided by voltage, that value is going to be 0, so you cannot write that. Okay, so literally in this equation I cannot write an equation for I4. Okay, so here, since I'm unable to write equation for I4, I'm going to write a super nodal analysis. So a super nodal analysis, when we're going to go for super nodal analysis, if you have a voltage source between two unknown voltage nodes, then you have to apply for a super nodal analysis. So my super nodal analysis is going to be, so I'm going to do this as I5, I6, I7. So plus I5 plus I6 plus I7 equal to 0. So what is I5? I5 and I4, can I cancel them? Because they're flowing in the same branch but opposite direction. Okay, so I can cancel it. I6 is nothing but V3 over 20. I7 is nothing but I can write this as I7, I can write it as V3 minus V4 over 4. Instead of that, can I write I7 as negative 2 amperes? So that will eliminate one more equation. So that's the reason I'm doing that. Okay, so I can write I7 as negative 2 amperes equal to 0. Okay, so let me solve. Okay, this is a big equation. When there is a supernode, there will be apply KCL at V2 and V3. Okay, we're doing it as a supernode. Now, at supernode, there are always two equations. One equation is going to be big like this. Another equation is a small equation. That equation is this value minus this value equal to V3 minus V2 equal to 40 volt. Okay, this is small equation. So at every supernode, you will end up having two equations. Let me solve this offline. So here, to simplify this equation, I'm going to multiply this with 20. Okay, when I multiply that with 20, I end up with 2V2 minus 2V1 plus V2 minus 20 plus V3 minus 40 equal to 0. Okay, again I substituted V3 equal to 40 plus V2 in this equation, and at the same time we found V1 equal to 20 volts. That's our first equation. So in the first equation we found V1 equal to 20 volts. So once I substituted everything, I end up with V2 equal to 15 volts. I found V3 also, which is not needed. Our goal is finding Ix. Ix equal to 15 divided by 20, which is 0.75 amperes. Now here I'm solving the same example, assuming he didn't give us the ground node. Okay, he didn't choose the ground node. Now we have a choice of choosing a ground node. Okay, so here I'm going to take this as VA. So instead of choosing this as my ground node, if I chose this as my ground node, assuming this as my ground, why did I choose that? As I told you in my previous videos, you can choose any node as a ground node. Usually we will choose a ground node where there are more elements connected. So if you look at here, this has 4 elements and these 4. So let me erase this. These 4 are connected together as another node. Okay, this is another node. So we can choose this as ground or that as ground. If I choose this as a ground, then I end up with a supernodal analysis. So to avoid supernodal analysis, what I did, I'm choosing this node as a ground. So that's going to be VA. Here is my VB. Our goal is finding Vx. So I don't think there is an issue finding VD. So let me take this as VC. That's VC. Here is VD. Okay, we don't need to find VC because of the current source. Now, okay, here, do I need to apply KCL at VB? I don't need to apply KCL at VB because I have VB. Because I have a voltage source between VB and ground. Okay, so for sure VB equal to 40 volts. Okay, do I need to apply KCL at VA? Yes, at VA apply KCL. Okay, here we cannot solve it by using the normal nodal analysis. In this case also, here also you have to choose since there is a voltage source between VA and VD. Okay, so let me solve this. I'm going to choose every current is going out. I1, I2, I3. Okay, so I1 plus I2 plus I3 equal to 0. So what is I1? I1 is nothing but 1 ampere. What is I2? I2 is nothing but VA minus 0 over 10 plus I3. Okay, since there is a voltage source, I cannot write for I3. Okay, even say for example, if you have some resistance there, some people say for example RX, people started writing this as I3 equal to 20 over Rx, which is wrong. Okay, because the voltage, whenever I'm writing I3, it must be the voltage drop across Rx divided by Rx. That's what you need to write. So if you have Rx, don't write it voltage divided by Rx there. Anyway, here in this case I don't have Rx, so don't worry about it. So I cannot write equation for I3. So what I'm going to do, I'm going to apply KCL again at VD. So I'm applying KCL at VA and VD. At VA and VD, apply KCL. Okay, so at VD, I'm going to take this as I4, I5, I6, I7. So I4, sorry, here I3 plus I4 plus I5 plus I6 plus I7 equal to 0. Okay, now I can cancel I3 and I4 because I3 is coming down, I4 is going up in the same branch, so I can cancel those two. Now what is I5? I5 is nothing but VD minus 0 over 20 plus I5 is nothing but VD minus VB over 20. This is I5, this is I6, and I7 is nothing but plus 2 equal to 0. So if I simplify, I already know VB value, VB equal to 40. Let me simplify this by multiplying 20. So when I simplify this, I end up with 20 plus 2VA plus VD plus VD minus VB plus 40 equal to 0. I end up with VA plus VD equal to minus 10. Okay. Remember, every supernode, every supernode, you will end up having two equations. One is very large equation, big equation like this. Another one is very small equation. That small equation is nothing but you know the voltage at this point, VD and VA. This is where we wrote the supernodal equation. At VA and VD, we wrote the supernodal equation. Now I have a voltage source between VA and VD. So I have VA and a voltage source and VD. Okay, I can say VA minus VD equal to 20 volt. That's my small equation at the supernodal analysis. Okay, so I have VA minus VD equal to 20 volt. So solving these two equations, I end up with VA equal to 5 volt and VD equal to, if I substitute 5 here, minus 15 volt. Okay, so I have VD value as negative 15 volt. Okay, so I can say IX. Okay, so in this case our goal is finding IX. IX is going from 0 to negative 15. Can I write IX equal to 0 minus VD over 20? So 0 minus of negative 15 divided by 20, which is positive 15 over 20. So IX equal to 15 over 20. That's the answer we have when we solved it in the previous example. We end up with the same answer. Okay, so it doesn't matter where you choose the reference value, but I thought I'm going to end up solving this by using nodal analysis instead of supernode, but when I came to write the equation, I end up with a supernodal analysis. Okay, I will solve a couple of more examples in the next videos. Thank you.